Hello everyone, welcome to the course Structure Analysis. I am Dr.S.Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. So far we have completed 31 lectures in the Structure Analysis course, and the last lecture is about analysis of 3-hinged arches. So initially we started discussing with analysis of 2-hinged arches and then 3-hinged arches. Currently we are at the 32nd lecture, which is the introduction to matrix method of structural analysis. So this is the 32nd lecture, introduction to flexibility and stiffness matrix method. So if you talk about the matrix method of structural analysis, under that topic, there are two topics are there. One is a flexibility matrix method, another one is a stiffness matrix method. So we are going to discuss what is this flexibility matrix method, stiffness matrix method, and how to apply this concept for analysis of continuous beams. At the end of this lecture, students can be able to understand the stiffness and flexibility matrix method concept and also differentiate between these two methods. Formulate the element stiffness matrix and then global stiffness matrix. Apply the methods to simple structures, for example, two unknowns, and then identify practical engineering applications. So, in this lecture, we are planning to discuss what are the various applications of stiffness matrix method and then flexibility matrix methods. So, matrix methods are the powerful tools used in structural analysis. So far, we have studied many methods. For example, for analysis of continuous beam, we have adopted three-moment equation method, moment distribution method, and Canis method. All these methods are available for the continuous beam. We can able to analyze and then we can able to calculate the final bending moments. But if you talk about all these methods, for example, the moment distribution method, Canis method, slope deflection method, all these methods are applicable only for the manual calculations. All these methods are more suitable for manual calculations. So, when the size of the structure, size of the problem is increased, for example, for a ground story or just a portal frame, I can go for a three-moment equation or a Kepler-Hahn theorem of three-moment equation or a moment distribution method, so on. But when my problem size is bigger, for example, instead of a portal frame, I'm supposed to analyzing complex structures, a multi-story building. In that case, we cannot able to adopt those conventional methods. We have to go for matrix method of structural analysis. So, they are essentially useful for indeterminate structures when the number of unknowns are more than available equilibrium equation, large complex structural system, and generally these two methods are preferred for computer based analysis, particularly the stiffness matrix method, more prevalently used for the programming, and it is a solver for StatPro, ETABS. All these software running behind nothing but the matrix method of structural analysis, in that the stiffness matrix method. So, there are two main approaches. One is a flexibility matrix method, also called as a force method, and another one is stiffness matrix method, which is a displacement method. So, in this lecture, we are going to detailedly discuss about these two methods, and we are going to discuss the importance and then applications of these two methods. In structural analysis, two fundamental relationships exist. One is the force produces the displacement, then another one is the displacement produces the force. So, based on which quantity is taken as an unknown, these methods are categorized. For example, forces are unknown. If you consider forces are unknown, then automatically we will be going with the flexibility matrix method. If you consider the displacements are unknown, then automatically we are going for the stiffness matrix method. For example, let us take a beam. For example, I will take the propped cantilever beam. Here HA is there and VA will be there, and then moment will be there, MA. So, this is unknown 1, unknown 2, unknown 3, and then this vertical reaction VB. let us say this is support A and B. So, here 3 unknowns and this is one is totally 4 unknowns are there. Now, the degree of static indeterminacy is equal to 4 minus 3 which is equal to 1. So, this in terms of force, this is having one unknown force which is we will consider is VB. If you consider VB is an unknown force and we are going to solve, then we are going to solve this problem by a flexibility matrix method because the force is unknown. In other terms, the same problem, if it is solved by the stiffness matrix method, then here the displacements are unknown. So, what would be the displacement? For example, this beam is going to deflect in this way and so this is, let us say it's a theta b, say is a theta b. So, here the theta rotation is a displacement quantity. If you fix the theta b is unknown, if you know theta b, we can able to calculate the bending moments at A. Then we will be considering the stiffness matrix method. First, we will discuss flexibility matrix method. Flexibility matrix method determines the redundant forces as primary unknowns. For example, you can able to see here VB is unknown. So, if you consider a force is unknown, then we will be considering a flexibility matrix method. So, this is the governing or general equation for a flexibility matrix method. You can able to see if it is a matrix, we can able to see the square bracket. So, it's a flexibility matrix. If you see the curly bracket, it is a vector. So, this force vector is a force vector and then this is the displacement vector. So, in the matrix method of structural analysis, the matrix is represented by the square bracket, for example, flexibility matrix, and the vectors are represented by the curly braces. Okay. So, displacement is nothing but the flexibility matrix multiplied by the force vector. Now, if you want to solve the problem, what are the various steps are involved in the flexibility matrix method? First, we need to calculate the degree of static indeterminacy. So, already I told you we have taken this problem in the previous slide. So, the moment, vertical force, horizontal force and one other force here. So, totally the static indeterminacy is equal to number of available unknown forces are 4, number of available equilibrium equations are 3. So, the degree of static indeterminacy is 1. So, this is HA, moment A, moment at support A and then vertical reaction VA and vertical reaction VB, totally 1, 2, 3, 4, 4 minus 3. This 3 is nothing but summation of all the horizontal force 0, summation of all the vertical forces is equal to 0 and summation of all the moment at any point is equal to 0. So, the number of unknown forces are 1. So, after calculating the degree of static indeterminacy only, we are going to proceed with the problem. So, in the first step in the flexibility matrix method is to calculate the degree of static indeterminacy and then select the redundant. So, what is mean by selecting the redundant? So, in this problem, we found that 4 unknowns are there after subtracting the equation 1 unknown. So, I can consider among these 5 forces, any force I can consider as an unknown force. For example, I may consider VB as unknown, I may consider VA is unknown, but in this problem generally it is advised to consider VB is unknown. Why? Because if you consider VB is unknown, then it will become a cantilever beam which is statically determinate structure. So, that is the advantage. So, we have given the option, we can choose the redundant force. What are the redundant force we are going to calculate it. Then we need to release the redundant force and obtain the primary structure, and we need to form the compatibility equation and also computing the flexibility coefficients. So, when we are solving the problem, all these things we are going to see how to calculate the flexibility coefficients and all. But this lecture is about just an introduction. And then we should solve for the redundant forces and finally calculating the member forces and reaction forces. Then in the part of the procedure, we have seen the flexibility coefficient. What are these flexibility coefficients are? So this is nothing but the displacement at coordinate I due to unit force at j. So if you take a beam, so this is the beam, and you can see displacement at displacement coordinate I due to unit force at j. What it represents, for example, if the cantilever beam having the proper free end, the displacement d is going to produce like this. It's a d, or we can also say this is a del, d or del. Now I have a two location, for example, ith coordinate and then jth coordinate. So displacement coordinate I due to unit force at j. So where the force is applied at j and then measuring the displacement at I, and then applying the unit force at I and measuring the displacement at j. Likewise. So while seeing the problem, we'll discuss. So Fij is nothing but displacement at I due to unit load at j. Okay. So this concept will be clearly explained while we are solving while we are discussing about the flexibility coefficients. For example, while solving the problem, before that I am going to discuss what is flexibility coefficient. So more understanding will be there in the next lecture, which is going to comprises of this flexibility coefficient. And what are the properties of the flexibility coefficients? First thing is, it's a symmetric matrix. What are the symmetric matrix? For example, we'll have these values like this: K1, K2, K3, K4, K5, K6, K7, K8 and K9. Symmetric matrix means this triangle is equal values, and this triangle also going to have the equal values. So these values and these values both are same, that is a symmetrical triangle. So that is a symmetric matrix, depends on the material and then geometry also, and based on unit load method. So flexibility method is nothing but based on the unit load method. And what is the advantages of a flexibility matrix method? Yeah, flexibility matrix also having some advantage, but we are not using this method more prevalently for computer programming and all, because it's having some major disadvantages also. But let us discuss what is the advantages. Good for the structures with a small number of redundants. So this is the major disadvantages also. Why? Because when we are dealing with the complex structures, we cannot able to go for a flexibility matrix method. This flexibility matrix method is suitable for manual calculations, and also in the academics for understanding the small concepts we'll use it. So conceptually, the flexibility matrix method is simple, less computational effort for simple indeterminate structures, useful for mostly hand calculation. So we can able to derive the disadvantages also from the advantages itself. Now coming to the disadvantages or limitations: difficult for highly indeterminate structures. So we cannot use these flexibility matrix for more complex structures. For example, analysis of a multi-story building like apartment buildings, so and so. Selection of redundants is not straightforward. That is also the major disadvantage. Not suitable for computer programming. That is a major disadvantage. Matrix size increases with redundants. So when the matrix size keep on increases, the complication of the problems also get increased, and it is going to become a tedious process. And where it is used: simple continuous beams where low indeterminacy, the number of unknowns are limited. generally used for property cantilever because the number of unknowns is 1 only. Simple rigid frames, we can apply flexibility matrix method. Manual structural analysis, only we can discuss in the structural analysis subjects. It's not going to use it in any complex problems, and basically for educational purposes. So now we are completed what is mean by flexibility matrix method, what are its various applications, limitations, flexibility coefficients, all those things. And now we are at the stiffness matrix method. So stiffness method determines joint displacements as a primary force. So as I told, the same problem I will take here, and this is going to deflect. Let's take a different color. This will going to deflect like this. So same problem was taken, and it's going to deflect like this, and this is the theta b. If I consider the unknown is theta b, then that is nothing but the stiffness matrix method. So because the unknowns are displacements, we are not at all going to discuss about the forces. So what we are going to calculate is a force vector, which is force vector, which is a product of the stiffness matrix multiplied by displacement vector. So force vector is equal to stiffness matrix multiplied by displacement vector. So K is a stiffness matrix, and del is a displacement vector, and F is a force vector. So this is the generalized equation for the stiffness matrix method. Now here what are the steps are involved? First we need to determine the degree of freedom. First we need to calculate the degree of freedom, how many number of degree of freedoms it's having. In case of flexibility matrix, we are supposed to calculate the degree of static independency, but in terms of stiffness matrix method, we need to calculate the degree of freedom. Quickly discuss 1 minute what is mean by degree of freedom. For example, let's take cantilever beam. We'll take a property cantilever beam. So number of degree of freedom, if you see, this is a fixed support. Let's say this support A and B. A is a fixed support, so it cannot move in any direction. So the degree of kinematic independency for the fixed support is 0. If you talk about the support B is a roller support, it can move in a horizontal direction, right? This can move in a horizontal direction. And another problem is the beam will deflect like this way. So it's going to form a theta, which is theta B. Okay, so it can move in a horizontal direction, that is one displacement coordinate. It also rotate, and that is a 2 displacement coordinate. So can I say the kinematic independency of this problem is 2 because it's having 2 displacement coordinates? But sorry, but we consider the beams are axially rigid. What it means axially rigid? The beams, it's not going to elongate or contract because of the temperature effects. Because of that, whatever the horizontal forces created, that is we are not going to consider. So it is axially rigid means this horizontal displacement, it's not a major thing. It's not a very small displacement will be there. It's negligible. So I'm not interested to calculate the horizontal displacement. So I'm interested to calculate only the theta b. So I can say the degree of kinematic independency of the property cantilever is 1 instead of 2. So only one unknown, that is theta b. So from here we calculated the degree of freedom of the which is kinematic independency. For a property cantilever B we calculated. So once you calculate the theta b, we can able to calculate all the reaction forces and then the bending moment at support A also. Develop element stiffness matrix, we need to develop it while solving the problem, we will see. And then also transform the global coordinates, local stiffness matrix to global stiffness matrix. Assembling the global stiffness matrix we need to do, applying the boundary condition, solve for displacement, this is nothing but the solving for a displacement, and finally computing the member forces. So, these are the various steps involved in a stiffness matrix method. But what is about the stiffness matrix? For example, this is derived for a spring. For example, you consider a fixed support, it's having the spring and this spring is having a suspended mass. So, let us calculate the elongation, the elongation stiffness is equal to, we can say, force required to produce the unit deflection. So, the axial deformation for this, it's AE by L. So, from these, it's a relationship between the stiffness and then force and displacement. So, stiffness for this K value, this K value for this one is AE by L for a spring, for a simple spring, relates nodal forces and then displacements. So, if you derive for the 2D 2 bar element of the stiffness matrix for the spring, it is like K minus K and plus K. Here we can able to see the diagonal matrices are symmetric. So, that is one of the property of the stiffness matrix. Now, these are the various properties of the stiffness matrix. As I told in the previous slide, it is a symmetric matrix and also is a square matrix. Leading diagonals are positive. Always you can see this is the leading diagonal. These values are positive. So, leading diagonal is positive and depends on material properties and geometry and sparse in large structures. Now, what are the various advantages of stiffness matrix method? Best suited for computer analysis because we no need to worry about the choices of the redundant forces, because the stiffness matrix method depends on the displacement, number of unknown displacements. Systematic procedure we have, it's not complex like a flexibility matrix method, handles large structures easily. That is why in a StatPro or a ETABS, the stiffness matrix method is a solver, not a flexibility matrix method. No need to choose the redundant forces. As I told, that is a major disadvantages of a flexibility matrix method, but here we do not have that issue. So, that is one of the advantage. Widely used in modern softwares. So, almost all the analysis and design softwares, we are using the stiffness matrix method as a solver. Even stiffness matrix method having some disadvantages. What is that? Larger matrix size for hand calculation. So, we can able to calculate the end moments of a continuous beam by using a moment distribution method within 10 minutes, not more than that. If the same problem it's solved by using the stiffness matrix method, definitely it will take a 25 minutes minimum, because the stiffness matrix method and then flexibility matrix method is not developed for hand calculations. So, those methods are suitable for a computer programming. So, that is a disadvantage here. So, more computational efforts are required for the manual calculation. But if it is a computer programming, it is going to take a minute only. Requires understanding of degree of freedom concept. So, in terms of flexibility matrix method, you should know what is meant by degree of static inerrancy, how to calculate that value. In terms of stiffness matrix method, you should know how to calculate the degree of freedom or kinematic indeterminacy. Then only we can able to proceed with the problem. And where and all it is used? Plane and space frames, trusses, finite element method softwares, for example, ANSYS, Abacus, any finite element softwares also, the matrix method of structural analysis is used, particularly a stiffness matrix method. Structural design softwares, as I told, StatPro, ETABS, SIPE, Tekla structures, all those things. High-rise building analysis. So, generally, which software you are using for high-rise building analysis? ETABS. So, in ETABS, it is used as a solver. Bridge analysis also we are using. And this comparison between the flexibility matrix method and stiffness matrix method is very, very important, and it will be asked in the examination also. First of all, the flexibility matrix method is there and then stiffness matrix method is there. Primarily, what are the unknowns? In the flexibility matrix method, forces are unknown, that is why it is also called as a force method. In this stiffness matrix method, the displacements are unknown, that is why it is called as a displacement method. It is best for, flexibility matrix methods are best for low indeterminacy, number of unknowns are less. Stiffness matrix methods are, it's used for highly indeterminate, the number of unknowns are very, very high. Computer use, we won't prefer the flexibility matrix method, we use the stiffness matrix method for the computer applications. Matrix size is based on the redundants, that means here number of forces is unknown. Matrix size is depends on degree of freedom, this is displacements are unknowns. So, number of displacements are more, then stiffness matrix method will be complicated. Number of forces are more, then the flexibility matrix method is complicated. Matrix size is based on, so either a redundance or the degree of freedom. Modern usage, for example, modern usage, the flexibility matrix method are very, very limited, whereas the stiffness matrix method very prevalently used in the almost all the softwares. These are some practical engineering insights. So, you should remember these things always. Flexibility method mainly for academics, stiffness matrix method, industry standards. For example, if you see ETABS is the industry oriented software. Almost all the industries uses ETABS, and all the consultancy, small construction companies using StatPro. All solvers are nothing but the stiffness matrix method. All FEM software is based on the stiffness method. As I told, Abacus, ANSYS, those softwares. Understanding both improves the structural intuitions. From the conclusion, this is a conclusion, matrix methods are essential in structural analysis because whatever the methods we use, all methods are mostly used for a manual calculation. Only the matrix method of structural analysis is used for the computer based calculations, analysis. So, matrix methods are essential in structural analysis. Flexibility method is a force based method. Stiffness matrix method is a displacement based method. Stiffness method dominates modern engineering. Both methods are important for conceptual clarity. So, if you understand the flexibility matrix method, you are going to well understand the stiffness matrix method. So, you need to read both to understand the concept. So, as a summary in this lecture, we have learned what is mean by flexibility matrix method, what is mean by stiffness matrix method, stiffness coefficient and flexibility coefficient, advantages and disadvantages of both the methods, importance, applications, everything. Thank you for watching this lecture. Thank you.